Okay, so this is the second half of problem 7 because I didn't see that we had two other parts to it. So here's what we got now. What we're going to be looking at is a parallelogram and how we can go about dealing with the pieces here. Now, here's the great thing about a parallelogram. Lines are parallel. So really what you're looking at are how many angles can we find based upon, sort of what we're looking at here. We have two parallel sides. This angle is 56. The alternate interior angle to that will be 3. So this angle 3 right here is also going to be 56 because those are alternate interior. Now I see angle 1 and angle 2 also alternate interior angles, but I don't know either of them yet. However, I have this triangle here. I got an 83, I got a 56, and then I got this 2. So we got to work backwards from the triangle. So when we look at it, 83 plus 56 is going to be 139. So that's 139. To find angle 2, I basically just have to find whatever 180 minus 139 is. Now, 180 minus 139 is going to be 41 degrees. So what I'm looking at here for problem 2 is going to be 41. And for angle 1 will also be 41 because they are alternate interior angles. And that's kind of the way we play these games with the angles, guys. We know the parallelogram that opposite angles are congruent. So I know that this would also be 83. And we can kind of work our way through figuring out the rest of it. But what's great is when we take that and move it to a special one like a rectangle, we got a lot of things here that are kind of important. If I look at this, I know enough about what I'm doing here to know that I have congruent diagonals. I know those diagonals bisect each other, but I also know that all of the angles are 90 degrees. So let's start with this 65 and start kind of playing our game all the way through. Okay. Here's what I know. If this one's 65, then I know that angle 5 right here also has to be 65 because they're alternate interior angles. So there's 65. I also know that since I have congruent diagonals and I know that those diagonals bisect each other, that means that this and this and this and this are all congruent to each other, which means what I'm looking at here are isosceles triangles. So that means I know that the base angles of these triangles will also be congruent. If that one's 65, then this one right here also has to be 65 because they're the base angles. Now, I'm going to use that information here to start kind of working my way through the rest because I know that every angle in a rectangle is 90 degrees. So if this is 65, that means this 2 has to be complementary with it. They have to add up to 90 degrees. So if that's 65, this one right here is going to be 25. And if that one's 25, again, we've got these base angles of this isosceles triangle here. This number 3 here will also have to be 25. And because we've got two sides that are parallel to each other, if this one's 25, then that 8 right there also has to be, come on, type for me. That also has to be 25. Now I got a bunch of these. All of my corners are taken care of. I am now at a place that what I have to do is to figure out these guys in the middle here. Not going to be too hard to do. For me, I'll do one first, and I think everything will kind of fall out. We're dealing with an isosceles triangle here. If the two bases are 25 apiece, that adds up to 50. If I take 180 minus that 50, that means that this angle 1 right here is going to be 130, so that all three angles add up to 180. I then also know that because these two are a linear pair, if that's 130, this one right here is going to be 50. So we've got angle 4. And I know that since these are vertical angles, angle 7 there is going to be 130. And this angle P, which is really weird that they have labeled it there but didn't say it, is going to be 50 on the other side. So this right here gives us everything that we are going to need for all of the angles on the inside here. And that is the end of this problem. So that's where I'm going to stop with this, and will be the second half of problem 7.